As part of the Open Digital Architecture reference implementation, we've defined the concept of an ODA component in IG 1171. But the question is, how do we create a standard for software-defined components? So we want to have a standard for all these different components making up the Open Digital Architecture, but we don't just want a textual classification of components, we want a real software-defined artifact. And I think Swagger for components. So how do we have something like the Open APIs, where there's a very well-defined specification that's both human and machine readable, that fully defines what is a component, what core functions does it have, what events does it publish and subscribe, how to manage and operate it, how to secure it. So this is what we're setting out to do as part of the component definition. Now what I'm going to do is I'm going to spend a few minutes going over what we've done so far. So what I've got is I've got a GitHub repository, which is the TM Forum RAND Git repository, where we've put in all of the work we've been doing to date. And I've got a blank Google Kubernetes engine space where I'm literally going to start from scratch. So first thing I'm going to do is I'm going to create a new cluster. I'm going to just accept all the defaults in creating that new cluster. And it'll just take a few minutes to spin up my Kubernetes cluster. While I'm doing that, I can go through more details about what I'm actually going to go and deploy. So as part of the BOS, the Business Operating System Catalyst, we created a very simple product catalog component. So the outside boundary of this is like the envelope of our component. Inside it, we have a number of microservices. We have a MongoDB microservice, a Commander BPM engine, a number of task execution, which is executing some of the process tasks within Commander. We have a manager microservice, and we have two microservices exposing the facilities of this product catalog through open APIs. So this is the concept of a component, and what I want to be able to do is be able to, without giving any of the software away, so keep these as just Dockerized images, but how do I, to the outside world, expose the capability of this component so that people can discover what APIs it has, can discover what data and what management interfaces this component has. So what we've created is, from the IG 1171, which defined these in a document, we've now created a YAML specification. So there's a specification. It's effectively following the patterns from Kubernetes, but really it's really just expressing this IG 1171, the data model, as a YAML document. And you see from this, so for example, it's saying this is a component. Its name is product catalog. The spec has a core function. So the green area, what is the core function of this component? And the core function then exposes certain APIs. So I'm exposing APIs, and here I'm linking to the spec. And the spec is just a URL to the open APIs. So you can go to that spec and see exactly what a product catalog API is and what it does, but I just need to link to it from the component. And I'm also saying that the implementation of this specification is in the product catalog, which is defined further down in the same manifest file. I'm saying it has a scopes of admin and regular. I'm also expressing some of the dependent APIs. So this component is dependent on there being a party API somewhere. And so saying it's expressing that dependency by saying there's a spec that I'm dependent on, and I'm expecting to go and discover an implementation of that API. Similarly, there's for notification reporting, there's a set of events. So published events, this as a catalog will publish a number of different events, or a catalog, a category, product offering, a price, specification. And for each one of these, I'm just expressing the schema of that data model that I'm publishing. So for each one of these, it's going to publish a certain schema of events. It's also publishing usage events. So that is not part of the product catalog. That's showing how I could charge for this component. So the component will natively expose usage charging events for its actual use itself. And secondly, I'm going to say I'm subscribing to events. So this particular component is subscribing to an import job. So you can kick off an import into the product catalog. Thirdly, I'm going to show the management. So a well-defined component will have a set of management interfaces. In this case, it's showing I have a service test where it's going to, this is the implementation of my service test, and it's saying I'm using the specification of the TM 653 service test API, where you can actually, test that this component is working properly through this API. And similarly, there's other APIs for things like alarms, for actually activating and configuring the component itself as a service, and so on and so on. So you can imagine defining like security schemes, etc. So fully defining what was in this IT 1171 as a machine and human readable YAML template. So that was the concept of the component, and there's an associated concept of what we're calling a canvas. So a well-defined component, I should be able to run on a standard canvas. And the reference implementation for this is a Kubernetes environment plus a number of other non-functional services. So you can imagine a Kubernetes environment lets me run the actual microservices and exposes the services for my software. But in order for them to be well-behaved services in a larger ecosystem, I also need some other non-functional services. So, for example, the ability to expose the APIs from my microservice in an API gateway, or the ability from a service or component to offer itself in a service registry so other components can discover what facilities it has. The ability to log in a standard way, to have like an event hub, so that all of these different events I'm going to publish and subscribe to can actually be plumbed together. Things like authorization. So when a component is expressing its security needs, I can link that into an authorization running in this canvas as a single operating environment. So that's the concept of a canvas. And what I'm going to talk about just is the Kubernetes implementation of this. So our reference implementation is using Kubernetes, and the concept is I can take like a manifest file for my component, which is expressing the intent of my component, and then I can apply that to Kubernetes. And I'm just showing how Kubernetes itself works. So the first thing is Kubernetes implements an intent-based API. So I can find some data models of the intents that Kubernetes manages, and Kubernetes can implement that, and it stores the intent in this etcd data store. And finally, in the Kubernetes architecture, it's very, very modular, and Kubernetes has these things they call controllers. So a controller monitors the intent, monitors the data model for an intent, and can then actually implement that intent. And in this case, this is the pod controller, which is monitoring pods being created in the API. And when one is created, it can go and actually deploy a pod in the infrastructure. Now, Kubernetes is very modular, has a number of different controllers. This is another example. So in this case, I've got a replica set controller. Now, in this case, this controller doesn't interact with anything outside of the API. It just looks for replica sets being passed in the API. And when you create a replica set, it then says, I'll create the corresponding pods to implement your replica set. And then it relies on this other controller to actually go and deploy the pod. So if I have a replica set which says I want 3 instances of a pod, then it can go and create the 3 pods, and this other controller will actually create those 3 instances. A third example of a controller is like an ingress controller. So in this case, the Kubernetes has defined a standard data model for what is an ingress, like how do I get data into my Kubernetes deployment. But in this case, the controller, the ingress controller, is managing services outside of Kubernetes. So typically, an ingress controller for a public cloud Kubernetes deployment is part of that cloud platform. So it's provided and it's specific to that cloud platform, and it's controlling the load balancer or the software-defined networking stack of that public cloud platform. And so what we're proposing is actually having a Kubernetes controller or a set of controllers that can then look out for the custom resources we will define as part of an ODA component, and that those controllers then being able to manage either other resources managed by Kubernetes or even external services running in that public cloud platform. And I could have an implementation of this canvas with specific controllers for the different public cloud environments. So this is the proposal, is to build an open digital architecture reference implementation in Kubernetes by building custom resource definitions for the ODA component YAML that I described earlier. And if I did that, what I could then do is I could have multiple components coming completely packaged in this envelope, which describes the features of that component in a YAML definition, and then having the Kubernetes API being able to interpret those custom resources and having controllers which can then manage all of the resources that are defined in those component manifest files. And not only could I control the resources, but also any other external services that we want to have as part of our canvas. Finally, one of the things I wanted to make sure we could cope with is having a proxy pattern. So even if the implementation of my component was somewhere else, I'm using an example of like a SaaS implementation. So an organization which has a SaaS implementation of a component can package up, how would I describe that SaaS implementation, and configure all my non-functional services so that other components can discover where the implementation is, or what APIs it supports, what data it supports. That should be possible by creating what we're calling a proxy component. So the proxy component will just point to that SaaS implementation and configure all of the other non-functional services so that the other components can discover that SaaS implementation. So for example, if I had an order capture component that required a product catalog, I could have that product catalog running in SaaS, and the order capture component could discover its services, discover the URL of the product catalog API it went to call, and be able to integrate completely automatically. So I go back to the demo. I'm actually going to go in and install. So from now, as you see, I've now got a Kubernetes cluster, brand new, nothing being deployed so far on it. And I want to go in and connect to that in my Cloud Shell. And what I'm going to do, I'm going to go into the TM Forum Git repository. I'm just going to clone this repository. Right, so now I've cloned that repository. There is a simple shell script which is going to install the canvas. I'm just going to run that. And while it's running, I'll talk through in the Git repository what it's actually doing. So in the repository, there are three areas. The first is what we're calling validation. So this is the JSON schema validation of a component. So we've got in fact, we've got a component definition, and the component will create APIs. So there's an API definition. But have a look in this. This is how we actually conform that a component should have a set of resources defined in it. And if you remember from the PowerPoint slide, we said a component had a specification with a core function, an event notification, management, security, and then the core function, for example, was an object with properties of exposed APIs, dependent APIs. So this is just in OpenAPI v3 schema expressing how do I validate that an input YAML is actually a well-defined component. And by applying these, which are custom resource definitions in Kubernetes, you can actually get Kubernetes to understand like what is the intent of a component and what is the intent of an API. And we will over time create other ODA relevant data models in Kubernetes to describe our intent. So that's in the validation. And that's enough for Kubernetes API to be able to take an input of a component. Then secondly, there's a thing called an operator. So this is the Kubernetes controller, which is then going to look out for those components being created in the API and then do something with it. So in this case, we've got an operator written in Python, and we're using this Python framework, which is called KOPF, or Kubernetes Operator Python Framework. So it's a very simple way of building operators using Python, and you can see what you really define in these scripts is a set of handlers. So it says KOPF on create. So when I create an ODA.tmforum.org component, at the moment we're in V1 Alpha 1 of the API standard, and then this basically says this is what I'm going to do when someone creates a component. And what I'm actually going to do is I'm going to get the exposed APIs of the component, and then I'm actually going to create API resources. So then the public cloud could then apply those to the whatever gateway is in that public cloud. Yeah, so this is showing the operator. And in the operator directory, there is the operator. There's a Docker file. You'd normally run the operator in Kubernetes itself. There's a manifest which actually deploys that operator. And then there's some other things. So there's setting the permissions for the operator and things like that. And then finally in here, there is an example. So in the examples, I've just got one example, which is the YAML definition of our product catalog. If I go back to my Kubernetes environment, so those things should all have been defined. So if I now go into my Kubernetes environment and I have a look, for example, I can look in the object browser. This is where I can see my custom resource definitions. There should be a definition here of an ODA tmforum.org API and component. So now Kubernetes itself understands the concept of a component. Now there aren't any components there at the moment. I haven't deployed any. But if I deploy my example component, it should appear here. And also it should populate the APIs in the API definition. So to deploy my example, I just copy this last line. So I can use kube control to interact with Kubernetes, even for our custom resources that we defined in these component YAML file. So I say kube control apply. Right, it's creating my product catalog component. As you can see, it's creating a component.oda.tmforum.org product catalog, and it's creating all the other resources that product catalog uses. If I now refresh this at the top, Now it understands, yes, there is such a thing as a product catalog running in my cluster. And if I look in here, my product catalog will have all the metadata that I expect it to have around its the core function, the APIs it exposes and consumes, and all the other information. And what that operator should have done is, if I go back to the APIs, it should have actually configured some APIs. So that product catalog exposed a product catalog API and exposed a process flow API. And in here, you can actually go and see that there's metadata describing what is the API and where is that API deployed. So it knows exactly where the API is deployed, and it knows what OpenAPI Swagger definition it's implementing. So I can then go into any public cloud environment and have the API gateway automatically configured with this information. So that is the concept of a component. And I can also show, the last thing I'll show is, if I delete that component, it should automatically clean up everything associated with it. So if I go in and say cube control, delete component, so I'm saying, so cube control now understands what a component is. If I'm saying delete this Vodafone product catalog component, it's deleted it, and it should automatically clean up these APIs which were deployed. So that's the concept, and this is very much the version 1 alpha of the concept, but over the next couple of months, as part of our work to Copenhagen, we're going to refine this and actually build out, real integration into the security and into the API gateway of our Open Digital Lab ODA Canvas.